Okay, Lab 2, Algorithm 3. For this one, we're going to convert a binary number into a decimal number. So base 2 into base 10. There's a linked video on here that talks through it in a little bit more depth. But a base 2 number, all of these 2 to the 0, 2 to the first power, 2 squared, that's what is meant here by base 2 number. And if you replace those 2's with 10's, that would give you our normal base 10 decimal that we're used to. Okay, so we're going to use a couple of different things here. This is easiest to do when we split the number into kind of individual cells to walk through the calculation, but what if our user wants to give us the numbers all together? How do we split that apart and so we have one number per cell? And then if we're going the other way, if we're going to go from decimal to binary, how do we go and put all of those numbers into the same cell? So we'll use a couple of different new functions here in Excel to do this too. Okay, I'm going to go ahead and copy and paste this, and then we can head over to Excel. To get started here, let's go ahead and use the same number that is given in the example, and then we can change it up a bit and try a few more numbers. So we'll go for this 217, and we'll use the initial binary of 1101101. And this is going to be easier to deal with if we go ahead and make some columns for it. Let's go ahead and start with an 8-bit number, but I want you to actually create something all the way up to a 16-bit number. And the reason for this, I'll show you, Excel does have a little function that can convert decimal to binary and vice versa, but it is a little bit limited in how many bits it can do. So let's go ahead and call this the binary column, and then we want another decimal column, and hopefully this decimal column will end up giving us that 217 from the example. Okay, so first things first, let's go ahead and see if we can move this 1101101 into here as ones and O's. And to do that, let me show you a little string manipulation tool that Excel has. I'll show you a piece of it here and then another piece of it, and then I'll fill in numbers underneath here. Okay, so there's a little string tool that I can say, grab the rightmost number off of this. And it will go ahead and get that very last number, but I have 8 numbers. If I change this around, I'm going to just add dollar signs here to maybe instead of add the first number, I'll copy this down so I grab the right 2 numbers and the right 3 numbers. Okay, so that's half of it. So I don't want 2 numbers or 3 numbers. I actually want what's going on down the left-hand side of this. So if you look at kind of this Christmas tree, 1 0 0 1 1 0 1 1. What's coming down the left-hand side of this Christmas tree is what I want. So I want the left side of what's happening on this right side. Okay, so you'll notice there's 2 arguments here. There's the number, and then the second argument is how many pieces we want to pull off of that. If I come over here and I say equals left, so this means I'm taking the leftmost number off of it. This is what I want. Let's see if I can grab that. Okay, there we go. So that's what we want. To do this right and left into one ginormous thing, what we can do is we can actually embed a function in a function. So I'm going to go ahead and add that left right on top of here. So I'm going to take that first number and grab the left digit off of it. So that will get us what we want. And I'm going to go ahead and put that across the top here. So I'll say equals left parentheses right parentheses, and I'll use dollar signs so that this original binary cell does not change. And I'm going to go for the first number in the first column and the second number in the second column. So that's why I have those guys numbered here, and then left, I'll always grab the first one off of that. Okay, so that's a little string manipulation tool. So now we have this 11011001, and it's copied over here, but now each number has its own little cell. Okay, so that's going to make it a lot easier to do our next calculation. So you'll see this first number is times 2 to the power of 0, and the next number is times 2 to the power of 1. And so what we can do is make another little row here and do this calculation that's shown in the note. So I have whatever the binary number is times 2 to the power of, and I already have these places labeled here, so I'm just going to subtract 1. So that will give me a 0 for the first one and a 1 for the second one. Okay, so this will give me all of the numbers I need to add up, so I can copy these across here. If you need to automatically size the columns on these, just grab between two rows and double click. So there's all of my numbers that I need to add up. And so my decimal, I'm actually going to do the decimal two different places. I'll do one where I sum them up right here. So I'm going to just add these guys all up. And another one, so Excel does actually have a binary to decimal function. And I'll show you in just a second that that little guy is a little bit limited. So yay, 217 matches 217, and we can see from the example we're doing this correctly. So then if we change this around and maybe add a different number on here, then it'll calculate it. Okay, what happens if I have a maybe a 16-bit number? So I'm going to just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so this is a much longer binary number. And I'm going to go ahead, let's make sure that this is in number format here. And I don't need those decimal places. There we go. I'm going to grab this binary to decimal function and Control C and Control V it down here, and bummer, now it's not working. So there's actually an upper limit to what that little binary to decimal function can do. And that's why I want you to take this from 8 up to 16 to see if you can convert a 16-bit binary number into decimal for this one. Okay, hopefully that won't be too hard for you.